Alright, these are the solutions to worksheet 7.1, area between two curves, and hopefully you didn't find this to be too hard to follow on the videos. We're basically describing a region that's created by one or more functions and trying to find the area of it. So we're using the same ideas that we've done before. In any one of these problems, the first thing you'd want to do is kind of get a visual of it. So you want to put one function in for y1, one in for y2. And let's go ahead and do a graph. So I've already selected my window. So here's the quadratic coming down, there's the linear coming up. And we're told that the y-axis acts as the third border, so we're really talking about this region right here. We want to find its area. That means f, the quadratic function, will be the top function, and g will be the bottom. So I'm going to put that on here. I'm going to put top there and bottom here. Okay? Because what we saw in the video is that the integral, or the area of this, is going to equal the integral of the top function, f of x, minus the bottom function, g of x. And it doesn't matter if they're above the x-axis, below the x-axis, one of each, doesn't matter. As long as we do top minus bottom, we're going to get that area. Now, what we do have to figure out is how far are we going. Now, we're starting at the y-axis here, so we know the bottom limit will be 0. We have to find that intersection point in order to know where to stop. We don't want to go all the way over to here. We want to stop right there. So we'll go ahead and intersect, enter, 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 and that's at x equal 2. Okay. All right, so that's the integral that would represent our area, and then we're going to let our calculator kind of figure this out. We could probably do this one without, but for heaven's sakes, why not use the calculator, right? So we'll go math 9s from 0 to 2. And f of x is my y1 minus g of x is my y2. Hit enter, and we get 9 1/3. So 9.333, or 9 1/3, or 28/3, or however you want to express it. Okay, so not too bad. Again, just got to understand what's my top, what's my bottom, and then set it up from there. Second one provides just a little bit of a challenge, nothing too bad though. Let's go ahead and take those off, and we'll highlight these. Okay, and we'll change our window up. We're going to look at a little bit more space on this one, and I do believe we have to expand our y out too. So let's see if that's enough. All right, so there's our cubic equation, and then the quadratic is going to come down. And what happens is we create two spaces that are in between. We have one here, and then we have another one here. We want to find the total area. So we want to find the area of this part, and we want to find the area of that part. Now you'll see that it's actually going a little bit higher, so I'm going to change my y max. We'll go up to 50. I think that might be enough this time. All right. So what that's going to require us to do is a couple things. We have to identify what's top and bottom at each spot and from where to where. So let's find this intersection point first. So if I go intersect and bring this over so that we're kind of close to that spot, enter, 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 I get an intersection of -3. So I know my first integral will be at -3. All right, and then how far am I going to let it go? Well, we got to get to this intersection. So I'm going to intersect down here. All right, get kind of close, and that's at -1. So the first area will be from -3 to -1, and according to this, the cubic function is the top. So this h of x will be the top. Well, actually, I don't want to write that here, because it's only the top for that part, right? So we'll put it in here. H of x, that's my top function in that interval, minus m of x, which is my bottom function in that interval. All right? So that right there will give us the area of this little section right in here. Now, we want to include this section as well. So that is, we'll add another integral from -1 to, now we've got to find the intersection here. So I go calculate intersect, we'll slide on up that way. And again, once we get kind of close, enter, 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 and that's at +3. And the thing about this section in here is that the quadratic now is the top function and the cubic function is the bottom. So I want m of x to be the top function there minus h of x, the cubic, dx. Okay, so in that area, they actually flipped over. Okay, so that's what we have. So when we go to find the area here, I'm actually going to grab this one. And this is going from -3 to -1. Now again, I want the cubic function to be first. So if I look at in here, this actually has y3 as the cubic. So I want y3 to be this right here. So I'm going to go alpha trace y3 minus, and then y4 is my quadratic. Okay. So that's the first one, and then plus, and I'll add another one in there from -1 to 3. And this time I'm going to go y4 minus y3. Flip it over and hit enter, and we get a total area of 49 1/3. All right. So again, hopefully this didn't feel too difficult to you. Really, it boils down to area between two figures is always the integral from start to finish of top minus bottom. That's the big idea. All right. If you do that, you're in good shape.